Hello guys, today I'm just making a video. This is mainly a past paper walkthrough for the topic of acceleration. This is going to be the first video for the series of the chapter forces. And yeah, so today's video we're just going to be going over the acceleration 1 question paper. It's mainly a walkthrough video. If you guys have enjoyed the video, please do like, share, and subscribe. Channel really helps a lot. And yeah, let's start with the video. All right, so hopefully most of you guys have this paper printed out and kept as well, also in digital format. So let's start with the video. All right, so question number 1. Remember to read the question carefully, okay? Figure 1 shows a skier using a drag lift. The drag lift pulls the skier from the bottom to the top of the ski slope. The arrows A, B, C, and D represent the forces that is acting on the skier and her skis. So in this diagram, you can see that there are multiple forces that is acting on the skier. You can see that there's a force C, D, B, and A acting on the skier. Okay, so hopefully you guys are going over this explanation. So the question is asking which arrow represents a force pulling the skier up the slope. So and tick one box. So what you have to do is you have to read the question carefully and look at the force which is pulling the skier up the slope. So the only force that is pulling the skier up the slope. Sorry guys. The only force that is pulling the skier up the slope is force D. As you can see, the arrow is pointing to the left, and that is the direction that the skier is planning to move, to the left. As you guys can see here, I'm just going to be using a different color. It is moving to the left, so that means it would be the force D. If you look at force C, that is acting upwards. Force B is the weight acting on the skier. Force A must be the friction force acting on the skier. So yeah, okay, so it's going to be force D. So that's your answer that you're going to put there. Remember to use black ink for exams, very important. So just going to zoom this out, but this is going to be the force D. That's going to be your answer for 1 mark. Okay, let's move on to the next question. Which arrow represents the normal contact force? So now what we have to understand is that the normal contact force is, in terms of definitions, it is like the force that is the opposite acting force. Okay, so you can say that if an object is at rest on a surface, for example, if there's an object on a surface, right, that object that is acting at rest on a surface, it exerts a force on the surface, and the reaction force acts at right angles to the surface. So you can consider as, weight acting downwards, and this will be called the normal, contact force acting in opposition to the weight of that object. Okay, so this is just an explanation on what normal contact force is. So which arrow represents a normal contact force? Here, like I told on the diagram, look again carefully. Force B is the weight. Okay, force B is the weight. So that means the normal contact force acting on this. What is the opposite force acting on B? The opposite force that is acting on B would be the force C. This one will be the normal contact force. Okay, remember, normal contact force is considered like, the opposite force that's acting. Okay, so that would be the force C. Okay, that's your answer for the second question. Okay, now let's move on to the next one. The drag lift pulls a skier with a constant resultant force of 300 newtons for a distance of 45 meters. Use the following equation to calculate the work done to pull the skier up the slope. You have been given the work done formulae, which is force times distance. Now what you're going to do is you're going to look, remember for physics, okay, specifically remember to always use the units. It's very important that you guys write down the units for exams, okay? So first of all, we're going to list what all is given to us. So you can see here, if you read the question carefully, the drag lift pulls a skier with a constant resultant force. So that means they're giving you the constant resultant force. This is going to be considered as the force. So that means your force is going to be equivalent to 300 newtons, okay? Very important. On top of that, they've given you the distance. So that means your distance is going to be, by the way, the symbol for distance can be considered as d. Sometimes I think displacement's using the symbol of s. So in this case, distance is equivalent to 45 meters. Okay, 45 meters. You've been given these two values. Now all you need to do is just substitute it into this equation to calculate work done. So work done, the symbol of work done is W. Okay, this formula is W equals F times D. This is the formula in the chapter of energy. Okay, so just do read on the chapter of energy. Okay, so that means W is equivalent to the force, which is 300 newtons, times distance, which is given to you as 45 meters. Okay, remember to write the units, N and M, okay, and which is going to be equivalent to, just need to bring my calculator, 300 times 45, just type it in your calculators and write down the values on the piece of paper. Okay, so 300 times 45, that is going to be 13,500 joules. Okay, it's going to be 13,500 joules. The units of work done is in joules, remember that. So it's 13,500 joules. Okay, that's going to be your answer for 2 marks. Next question. At the top of the slope, the skier leaves the drag lift and skis back to the bottom of the slope. Figure 2 shows how the velocity of the skier changes with time as the skier moves down the slope. So in figure 2, remember to observe the graph carefully. We can see that there's velocity in meters per second on the y-axis and time in the x-axis. Okay, so okay, after 50 seconds the skier starts to slow down. Okay, and the skier decelerates at a constant rate, coming to a stop in 15 seconds. Draw a line on figure 2 to show the change in velocity of the skier as she slows down and comes to a stop. So if you read this carefully, after 50 seconds the skier starts to slow down. So that means at a point here, this is 50 seconds, right? What we're going to do is, since that skier starts to decelerate at a constant rate, coming to a stop in 15 seconds. So that means it's going to be a straight line, which is drawn downwards. So it's in 15 seconds. So that means 50 plus 15 is going to be 65 seconds. Now look carefully. This is after 50 seconds. So we're going to count the time of 50 seconds, and then we're going to be adding the 15 seconds extra. So if you do 50 plus 15 seconds, that's going to make it 65 seconds. Now remember, in graph questions, you have to look at the number of squares. I'm just going to be zooming in, okay? How many squares are between 0 to 10? There are 5 squares between 0 to 10. So there's 1, 2, 3, 4, 5. 5 squares. So that means it's going to be 10 divided by 5. And we're going to find out the value of each of one square. 10 divided by 5 is going to be 2. So that means 1 square is 2 seconds to the right. Okay. So that means 65 is going to be, this is going to be 62, 64, 66. So that means 65 is over here. Okay, right in the middle. It's in the middle of that square. Okay, I'm just going to show this clearly again. This is 62, right? This is 64. This is 66. 65 is in the middle of 64 and 66. So it's here. This is going to be 65. This is really important in graph questions. So what you're going to do is, since she decelerates, right? Yes, since she decelerates at a constant rate, so that means it's going to be a straight line all the way to 65. This is not a very accurate graph, but you get the idea. This is going to be answer. It's going to be a straight line, which is going to be drawn from 30 meters to 0 meters. And it's going to finish on the x-axis at 65 seconds. Okay? Remember, this is really important. They mentioned the word decelerates at a constant rate, so that means it's a straight line moving downwards. Okay? This is going to be your answer for 2 marks. Okay? Let's move on to the next question. Okay. Next question is related to the chapter of stopping distance. There should be a formula in this. The total stopping distance of a car has 2 parts. One part is the distance a car travels during the driver's reaction time. This distance is often called the thinking distance. What distance is added to the thinking distance to give the total stopping distance? So, you know, the formula is technically thinking distance plus braking distance, which is going to give you the total stopping distance. Okay? Okay, so that's like what stopping distance is. So what we're going to do is, since they had asked us to find out what distance is added to the thinking distance, what we have to do is, you just need to mention that it's the braking distance. So, but there's another way of writing this. You can mention that it is the distance traveled under the braking force. Now, this is the same thing as the braking distance. So I'm just going to be writing it here. Okay. So this is, I'm just going to be using another font pen. This is the distance traveled under the braking force. Okay? Under the braking force. This is the same thing as the braking distance. I'm just going to put a semicolon here just to show you that, this is the same thing. This is the braking distance. Okay? This is the same thing. The distance traveled under the braking force is the same thing as the braking distance. Okay? Let's move on to the next question. Okay, now the next question is, the graph shows the relationship between the speed of a car and the thinking distance. So you can see that there's an x and y axis. So on the x-axis, you guys can see that there's the speed in meters per second. Remember the units. The units of speed is meters per second. And the thinking distance is on the y-axis. And that the units of the thinking distance is in meters. Now, describe the relationship between speed and thinking distance. So when they ask you describe the relationship, you're just going to be talking about the relationship between the speed, which is on the x-axis, and the thinking distance, which is on the y-axis. Okay, so these are some important factors to consider. So what you can see on the graph is you can see that there's a straight line running through the origin. So first of all, check how many marks the question is. So this question is worth 2 marks, so we have to mention 2 points. So what we're going to write is the keyword that this is directly proportional, because it's a straight line running through the origin, right? I'm assuming, yeah, it's a straight line running through the origin. So you're going to write this word is that it is directly proportional. Okay, it is directly proportional, and you can mention that it increases in the same ratio. Okay, it increases in the same ratio. That's another point that you can write. You can also write that if speed doubles, right? If speed doubles, then thinking distance doubles. Okay. You can also write that there's a positive correlation. You can also write, that as speed increases, so does the thinking distance. That's another way of saying it. You can also write as one increases, the other increases. You can also mention that as thinking distance increases, speed increases. These are some other points that you can mention in this case. Okay, let's move on to the next question. The next question is stating that a diagram is showing 2 students investigating reaction time. So you can see a diagram showing 2 students. One student holds a 30 centimeter ruler. Then let's go. As soon as the second student sees the ruler fall, she closes her hand, stopping the ruler. Now the further the ruler falls before being stopped, the slower her reaction time. So the question is stating one student always holds the ruler the same distance above the other student's hand. In this experiment, what type of variable is this? Put a tick in the box next to your answer. So read the question carefully. One student always holds the ruler the same distance above the other student's hand. Now, the key word here is, if you look, is the same distance. Now, this means that they're controlling something, meaning that they're keeping something same. So that refers to the control variable. I think this box would be the independent variable. I'm not sure why it's not filled in this case. Okay, so just ignore that. So in this case, it's going to be the control variable. You're going to put a tick on that, because control variable is a variable, or it's an instance where you keep something, you control it, you keep it the same throughout the full investigation or experiment. Okay, so that's why it's the control variable for 1 mark. Let's move on to the next question. Describe how this experiment could be used to find out whether listening to music affects reaction time. So what you can mention for 2 points would be that the experiment is done and the student experiment is done and the student listens to music slash using an iPod. You can mention that as well, but in this case you're not going to mention that. Okay, you can also mention that the experiment is repeated when the student is not listening to music. When the student is not listening to music. Okay, let's move on to the next question. Okay, yeah. The following information is written on a label of some cough medicine. Causes drowsiness. Do not drive or operate machinery. How is feeling drowsy, sleepy likely to affect a driver's reaction time? Remember, if the person's feeling sleepy, that means they'll take more time in order to react. So that means the driver's reaction time is going to increase. So that means it's going to increase it. Okay? So that means the reactions are much more slower. So that's something that you can mention for 1 mark. Let's move on to the next question. 3 cars, X, Y, and Z, are being driven along a straight road towards a set of traffic lights. The graphs show how the velocity of each car changes once the driver sees that the traffic light has turned to red. Okay, so you can see that there are 3 graphs here. Which one of the cars, X, Y, or Z, stops in the shortest distance? And this is for 1 mark. So, stops in the shortest distance. So you're going to look for something that will have the shortest distance, that would have the lowest time. So in the X graph, you can see that the time it takes is about 8. In the Z graph, you can see that the time it takes is about 6. Whereas for the Y graph, the time it takes is roughly, you can estimate it to roughly 4 point something, 4.4 range-ish, 4 to 5 range-ish. So that's less. That time is less than that of X and Z. So that means you're going to be choosing Y in this case. Okay? That's going to be your answer. Y is one of the cars which stops in the shortest distance. Okay, let's move on to the next question. Next question is, a car and a bicycle are traveling along the same straight road. They have stopped at road works. The graph shows how the velocity of the car changes after the sign is changed to go. So you guys can see, look at the graph clearly, time, which is on the x-axis, and the units of time is seconds. And velocity, which is on the y-axis, and the units of velocity is meters per second. These units are really important in physics. Okay? Between which 2 points in the graph is the car moving at constant velocity? So, if you look at the graph, at constant velocity, it would be between, it could be between K to L. However, that's acting at the origin, right? Between K to L, there's no velocity, so we cannot use K and L in this case. So you cannot use K and L because the points between K and L, that has 0 velocity. You can see that it starts from 0. So the only straight horizontal line would be M and N. This is where you're going to be having constant velocity. It's between points M and N, okay? M and N. Between which 2 points in the graph is the car accelerating? So on a velocity time graph, when there's acceleration, it's considered, in this case, we're going to consider the straight line. That's where it's accelerating. So that's between points L and M, because it's a straight constant line going upwards. So that means the car is accelerating. L and M, okay? All right, let's move on to the next question. Between the sign changing to go and the car starting to move, there is a time delay. This is called a reaction time. What is the reaction time of the car driver? So there's a time delay between the sign changing to go. So that means the car is going to start accelerating. So that means we're going to zoom in closely to the graph. Okay, we're going to zoom in closely to the graph, and you can see that this is one way of finding what 1 square is worth. Okay, So you know that 1, and there are 5 squares between 0 and 1 if you count it. So that means it's 1 divided by 5. This is going to give you the value of 1 square. So that means it's going to be 0.2. The value of 1 square is 0.2. Okay, so in this case, if you zoom in closely to the graph, right, if you zoom in closely to the graph, this is where the car starts to accelerate. So that means if you do 1 minus 0.2, that's going to be 0.8. This is the point at which the car is going to start accelerating at the start of go. So that means it's going to be 0.8. That's going to be your value. In this case, the reaction time is going to be 0.8, because we know that the straight line between L and M is when the car is starting to accelerate. Okay? And at that point, at point L, is when there is a there's a time delay. And that's reaction time of the car driver, which is going to be 0.8 seconds. Okay? Next question. Which one of the following could increase the reaction time of a car driver? Tick the box next to your choice. Driving alcohol, wet roads, worn car brakes. So it's going to be wet roads has nothing to do with the reaction time of a car driver, because wet roads is related to the braking distance or something related to that. Even worn car brakes is related to that. Drinking alcohol is going to affect the reaction time of a car driver, so that's going to be your answer. Okay? Next question. The cyclist starts to move at the same time as a car. For the first 2 seconds, the cyclist's acceleration is constant and is greater than that of a car. Draw a line on the graph to show how the velocity of the cyclist might change during the first 2 seconds of its motion. Okay? So, for this type, you have to read the question carefully. Is that the cyclist starts to move at the same time as a car. So that means it's and for the first 2 seconds, the cyclist acceleration is constant. Draw a line in the graph. Okay. So that means as the car is moving at 0.8, we're going to draw a straight line that is going to be starting at 0.8 seconds, because that is the point, that's point L, right? That is a point at which the car starts to move. Okay? And on top of that, these are some of the keywords. Okay, we're just gonna we're just gonna highlight it. Yeah, we're just gonna highlight it. The cyclist moves at the same time. That's one of the keywords. On top of that, it is greater than that of the car. So that means this line is going to be steeper than L and M, starting before L. Okay? So how are we going to draw this? That means it's going to start at 0.8. And it's going to be looking like this. I'm just going to be drawing it using purple. So it's going to start at 0.8 and it's going to touch somewhere here. And it's going to be somewhat steeper. And, you can draw it like this. Hopefully this is right. If this is not correct, just edit it on your side as well. It'll be great. Point it out in chats. In this case, this is what I'm assuming will be the right answer. It's a straight line. It's starting at 0.8 seconds. And it's much steeper than L and M. Just starting before L. Okay? This is your answer for part D. Okay, let's move on to the next question. Okay, this is more calculation based. Okay. On 14th October 2012, a skydiver set a world record for the highest free fall from an aircraft. After falling from an aircraft, he reached a maximum steady velocity of 373 meters per second after 632 seconds. Draw a ring around the correct answer to complete the sentence. This maximum steady velocity is called the. Now, when they use the keyword maximum steady velocity, they are referring to the word of terminal velocity. This is one of the keywords so that you guys know what this means. So that means the answer is going to be terminal velocity. Okay. All right. Next question. Okay. Is there any other data? Okay. The skydiver wore a chest pack containing monitoring and tracking equipment. The weight of the chest pack was 54 newtons. The gravitational field strength is 10 newtons per kilometer. This is how you pronounce it when they put a slash. When they put a slash between n and kg, you read it as newtons per kilogram, not kilometer. Sorry. Calculate the mass of the chest pack. Okay. So what we're gonna do here is that first of all, you're gonna list what are the values that are given to you. Okay. So you're given the weight. The weight is given to you as 54 newtons. The gravitational field strength, by the way, the weight abbreviation is W, and the abbreviation of gravitational field strength is G. The value of G is 10 newtons per kilogram. Remember to write down the units, so important. Now, the formula that's connecting weight, gravitational field strength, and mass is the formula using W equals mg. Okay, where W stands for the weight, m is the mass, g is the gravitational field strength. So we're going to rearrange this in terms of weight and gravitational field strength. So that means mass is equivalent to the weight divided by g. So mass is equivalent to the weight, which is 54 newtons, divided by the gravitational field strength, which is 10 newtons per kilogram. Okay. All right. This is how you substitute the values. The weight was 54 newtons, and G's value was 10 newtons per kilogram. You're just going to substitute that in a calculator to get the mass as 5.4 kgs. Okay. 5.4 kgs. Okay. Now, the next question. During his fall, the skydiver's acceleration was not uniform. Okay. Immediately after leaving the aircraft, the skydiver's acceleration was 10 meters per second square. Okay. Without any calculation, estimate his acceleration a few seconds after leaving the aircraft. Explain your value of acceleration in terms of forces. Now, the estimate is roughly between 0 and less than 10, so it's roughly like 6.5. You know, you can mention something like less than 10, so you can put an estimate that it's 0 less than acceleration point less than 10. This is somewhat the estimate range. What you can put the estimate as is 6.5, but this is something that you do need to mention. The estimate in this case would be 6.5. Remember to put the units, so important that we put the units, meters per second squared. Okay. Now the explanation why this is less than 10 meters per second immediately after leaving the aircraft, is because there is some upward force, meaning there's drag. There is air resistance. There's air resistance, which is drag. Okay. And this means reduced resultant force. Okay. Reduced resultant force. That's your answer for roughly 3 marks. Okay. Let's move on to the next question. Without any calculation, estimate his acceleration 632 seconds after leaving the aircraft. It's going to become 0. Actually, the reason is because terminal velocity. Okay. It's because the upward force is equivalent to the weight, which is gravity. Okay. And that means the resultant force is 0. This is going to be answer for roughly 3 marks. let's move on to the next question. Hopefully you guys have written that down. Okay. A high-speed train accelerates at a constant rate in a straight line. The velocity of the train increases from 30 meters per second to 42 meters per second in 60 seconds. Calculate the change in velocity of the train. Now, the change in velocity, right? Sometimes change in velocity, do remember that, sometimes change in velocity is written with a triangle. This is called a delta triangle and V. This just means change in velocity. These notations of symbols just means change in velocity, okay? So the change in velocity, they have given you the initial, which is 30 meters per second, and they've given you the final velocity, which is 42 meters per second. So what you're going to do is, in the change in velocity is going to be equivalent to 42 meters per second minus 30 meters per second. Write the units, so important. 42 minus 30, which is going to be 12 meters per second. Okay, 12 meters per second, that's going to be answer. Okay, let's move on to the next part. Use the equation in the box to calculate the acceleration of the train. Show clearly how you worked out your answer and give the unit. Okay, now remember the unit of acceleration is meters per second squared. Be really careful what you're circling. It is meters per second squared. Okay, I'm just going to use a different font for that. It is this one over here. Okay, it is meters per second squared. If you zoom in, there's a square next to it. Okay, that's one of your units for acceleration. So now you're given the change in velocity, you're given this value, which is 12. Now you just need the time. Time is given in the question. Read the question carefully. Time is over here, 60 seconds. Okay, so that means your time is going to be equivalent to 60 seconds. I'm going to just put S. Your change in velocity is going to be equivalent, you have found it in the above question, 12 meters per second is 12 meters per second. Now, your acceleration is using this formula. By the way, by heart this formula. Acceleration is equivalent to change in velocity divided by the time taken for change. Okay? In simple words and symbols, it just means acceleration is equivalent to change in V divided by time. Okay? Just going to bring it here and go. Okay? So that means that acceleration is equivalent to, you just need to substitute this, 12 meters per second m/s divided by time, which is 60 seconds, given in the question. That's going to give you your acceleration, which is 0.2 meters per second squared. Really important. Okay, 0.2. Write it even in the answer. 0.2 meters per second squared. Okay. All right, let's move on to the next question. Which one of the graphs, A, B, or C, shows how the velocity of train changes as it accelerates? So, it's going to be a straight line, because if you look at the clue words, from the beginning of the question, it's been saying that the high-speed train accelerates at a constant rate in a straight line. So that means it's not going to be curving, nor is it going to be a horizontal. It's going to be B. It's going to be this graph over here. Okay, it's a straight line, and yeah, as it accelerates. We're just going to mention, we're going to write it here, that it's graph B. Okay. This seems to be the paper is completed. If you guys have enjoyed the video, please do like, share, subscribe to the channel. It really helps a lot. And do comment below on what your thoughts are about this video. And I think that's it. All right. Bye, guys.